Hello, my dear friends. Welcome to BYJU'S Exam Prep, the most comprehensive preparation app for GATE and ESE preparation. So, very good evening. Good evening, guys. So, please do let me know whether my audio and video is all good, all perfect. Okay, so everyone eagerly waiting for this session because mechanics is a subject where you can actually score very easily if you are very good at the concepts. Okay. सर मॉक नहीं होगा आई रोलेक्स आई नीड टू अपडेट ऑन दिस एक बार मैं चेक कर लेता हूँ है ना एक बार मैं लेट मी सी कि प्लान क्या है हमारा ठीक है एज पर आई नो एक तो मॉक टेस्ट रखा है बट कब होगा लेट मी चेक विद दैट राइट ओके एंड आई थिंक इन अवर ऐप ऑल्सो वी आर हैविंग अ मॉक टेस्ट सो डेफिनेटली यू कैन अटेम्प्ट दैट अगर लाइव नहीं है बट डेफिनेटली ऑन अवर ऐप वी आर हैविंग द मॉक टेस्ट तो यू कैन गो एंड अटेम्प्ट दैट बार्क मॉक टेस्ट एंड डेफिनेटली विल बी हैविंग एन अपर हैंड ओके तो आप उसको तो डेफिनेटली आप उसको अटेम्प्ट कीजिए गुड इवनिंग हर्षित गुड इवनिंग कैसे हैं आप लोग सब ऑल गुड ऑल परफेक्ट एवरीवन गुड इवनिंग गुड इवनिंग fine so today we'll be taking some problems of mechanics because this is important for both mechanical and civil aspirants so please do join as soon as possible so that we can start off the session and we'll be discussing some very good level of questions because BARC में questions का level थोड़ा सा ऊपर होता है as compared to that of GATE ठीक है मतलब almost similar भी हो सकता है but कोई some questions are like having a higher level as compared to that of GATE so mechanics is a subject where you can expect a slightly good level of question okay fine so very good evening I hope everyone knows about me and let's skip to this part yes on 9th of April Abhinav sir will be coming live at 12:30 and he'll be discussing about the most important tips and techniques to excel in GATE 2024 why I'm saying this is important because whenever you are going for the starting of any preparation right always you should be having a proper start if the start is not proper definitely the end result won't be getting right so always you need to understand whenever you're starting your preparation journey you have to start with a we can say what were the mistakes which we have committed so that you cannot go to that mistake so definitely you need to work on that so these all proven tips and techniques will be shared by Abhinav sir okay fine apart from this as you all know your GATE ESE Mains 2023 batch has been launched and it's a comprehensive practice course for ESE Mains so those students whose prelims has been qualified or pre has been qualified it's a must watch it's a must practice and those who are planning to give for 2024 and if you are covered with your syllabus definitely you can also join and you can practice some mains level questions okay good evening chalo shall we begin with the questions yes yes or no अरे हाँ ना बोलो भाई रोलेक्स हर्षित वेरी गुड इवनिंग आई थिंक मैं चेक कर लेता हूँ फ्रॉम माय एंड आल्सो इट्स ऑल गुड यस perfect yes चलिए let's move to the questions question number 1 on your screen I'll be taking mostly the logical questions slightly numerical oriented but these kind of question you can definitely expect in the examination a rigid rod EF moving in a plane having a velocity VE at point E and VF at F which are parallel to each other. So we have to make sure you have to concentrate on this point. Both the velocities are parallel to each other. Okay, fine. So what you have to do is which of the following statements cannot be true? Which of the following statements cannot be true? You have to see one by one different so make sure you are identifying the correct options okay so first option is both VE and VF are perpendicular to EF can we have a situation that both VE and VF will be perpendicular to EF yes we can have that situation that we call it as pure translation when both VE and VF are parallel to this link EF, we can get that situation. So definitely this cannot be false. This is a true statement. Okay, so you can eliminate option A. Good evening, Rishi. Good evening. Talking about option B, the magnitude of VE is equal to the magnitude of EF and the angular velocity is 0. Can we have a situation like this? If VE and VF both are parallel, if they are having equal magnitude, can we have a condition that the angular velocity will be 0? Yes. Okay, Rolex is saying option D. Sir, this is also possible. If I say, let us suppose this is a rod. Okay, this is a rod, right? This is point E, this is point F. and both are having same velocity. This is VE, this is VF, right? And definitely these are perpendicular to this. So in this scenario, your angular velocity of the rod will be definitely equal to 0. So this is also possible, right? Now talking about option C, the velocity V is not perpendicular to EF and angular velocity of EF is non-zero. Let us cross check option C. Let us cross check option C, right? So let us suppose there is the rod I'm talking about. This is the rod EF, right? And in this case, the velocity is not perpendicular to this one. Okay, let's say this is making an angle of alpha. But the thing is, as they have clearly mentioned, VE and VF are parallel to each other. So we can surely say this VF will also be making the same angle as that of alpha. Yes. Now, as we know that this is a rigid rod, can we say VE cos alpha is exactly equal to VF cos alpha, right? Okay, so from here we can get a very important information that VE must be equal to VF. If they are parallel, they should be equal. Okay, now they are saying the angular velocity is non-zero. Now for creating the circular motion, can we say the sine component is responsible, or we can say the angular velocity of the rod will be equal to VE sine alpha minus VF sine alpha, right, divided by the length EF. So here this is coming out to be 0. So if according to statement number 3, if VF is not perpendicular to EF and angular velocity of ES is 0, this is basically not possible. This statement cannot be true. So option C is the correct answer. Option C is the correct answer, because if VE and VE is not perpendicular to EF, so definitely in that scenario, your both the magnitudes will be same. And in this case, the angular velocities, if both are parallel, they will never have an angular velocity. Is this clear? Fine. Is this clear? Now, if they're saying if VE is not equal to VF, if VE is not equal to VF, right? So if VE is not equal to VF, in that case, the angular velocity will be a non-zero magnitude, and that is quite sure because the sine component is responsible. And if VE and VF is not equal, so we can surely say that the angular velocity of the rod will be a non-zero. This is a correct statement. So option D we can eliminate. So correct answer is option C for this particular question. Is this clear? Rolex, Rishi, Harshit? Option C is the correct answer. Simple. By only having a basic understanding of the velocity, we'll be able to have a clear understanding. Okay, fine. Chalo. Next question on your screen. A block of mass 5 kg is released from rest as shown in the figure from position A on an inclined surface. The coefficient of friction between the block and the plane is 0.2. What will be the velocity at which it will touch the ground? What is the velocity at point B? Very easy question. Very easy question. What will be the velocity at point B? Simple. And they have given you the coefficient of friction. That means if you are trying to apply the conservation of energy, you have to include the energy, the work done on the friction. The work done on the friction also you have to consider that. Okay. So let us suppose this total length is L. I'm saying this is theta. So can we say this is your, let's say this is distance X and this is your height Y. Okay. This is height Y. So if I want to apply the conservation of energy, so at point A, we'll be having potential as we'll be having only potential energy because it is released from rest. So we can say at this point, it will be M into G. Let's say this height is Y. Okay. And this distance is X. So mg into Y should be equal to, at this point, what will be the energy? Right? It will be half mvb square. Right? But the thing is, because of the friction, some amount of energy will be lost. Some amount of energy will be lost. If I try to draw the free body diagram, we'll be having mg cos theta, will be having normal reaction. This is your mg sin theta. Okay, and this is the direction of friction. So we need to overcome that friction. There will be some amount of energy being lost over friction. So I can say what will be the friction force? So F is equal to mg sin theta. Mg sin theta, right? Or we can say the body is trying to move in the downward direction, or we can say over here simply, sir, F is equal to mu into N. where n is mg cos theta. Yes, n is mg cos theta. So we can say mu into mg cos theta. And what is the distance travel? Let us say this is L. L is a total distance travel. So I can say minus mu mg cos theta. This is the force into displacement, that is L. This will be the energy lost. Yes, this will be the total energy loss, right? So I think mass will be cancelled out. So we'll be having g into y is 30 meter, half into vb square minus mu value they have given as I think 0.2 into 10. Now what is L cos theta? If this is theta, L cos theta will be 50. L cos theta will be 50, right? So from here, can we calculate the value of vb? Can we calculate? I think. One second. It will be plus, right? Because the energy will be subtracted from the initial value, right? So I can say that whatever potential energy that we are having minus mu into mg cos theta into L, that should be equal to half mvb square. Yes, because that amount of energy will be lost. So initially we are having only potential, so it will be converted into kinetic energy, but due to this friction we'll be having some losses energy. So you'll be taking this as positive. This will be vb square will be equal to half vb square will be equal to g into 30 plus this will be 100, right? This will be 100. Okay. So from here vb is equal to 60g plus 200 root of this. Tell me what is the value you are getting. Yes. Are we getting this? Are we getting this value? This will be minus. Okay, so this is 300. This is root of 100 into 2. Root of 100. This will be 300. This is 200. Okay, let me write it directly. This will be 300, 200. So 2 into 200 VB square. So VB is equal to 20 meter per second. Yes, 20 meter per second. I think option C is the correct answer. Option C is the correct answer. Yes. Okay, so only thing is we are having initial as the potential energy, right? With the movement of the downward, if there was no friction, we can directly say mgy is equal to half mv square. But because of that friction, some energy will be lost, that is F into X, frictional force into the total distance travel. What is friction force? That is mu into mg cos theta into total distance. So we can say mu into mg cos theta total distance. So what is L cos theta? That is equal to 50. L cos theta is equal to 50, right? So just place it over here. You will be getting VB is equal to 300 minus 100, that is 200 into 2, 400. Root of 400 is 20 meter per second. Option C is the correct answer. Okay, option C is the correct answer. Okay, is this clear? Fine. Normally, while applying the law of conservation of energy, we normally not taking that friction into consideration. But if you are taking that friction into consideration, you have to subtract that some portion of energy will be lost to overcome that friction. Okay, chalo, question number 3 on your screen. Question number 3 on the screen. Chalo, a turntable is rotating at a rate of 30 rpm. A small block of mass m is kept on a table at a radius r. Given that the coefficient of friction is 0.1, what will be the minimum radius for the mass to just overcome the frictional resistance? So let us suppose if we see the top view, there is a turntable and there's a mass being kept over here from the center. Okay, from the center. So they are saying what should be the minimum radius for the mass to just overcome the frictional force. Now, what is the tendency of the body? The tendency of the body is to move outside due to the centrifugal force, that is mr omega square. And if you try to visualize, the mr omega square will be nullified by the frictional force. So at limiting condition, they are saying just to overcome, that means I'm talking about impending motion. Okay, for impending motion, we can say that mr omega square is equal to the frictional force, right? So this is your mr omega square. This is the frictional force. This is the normal reaction. This is your weight W. I think they have given as the weight M in terms of M they are giving. Okay. So this will be mr omega square. This is mu into N. What is N? That is mg into mg. This is mr omega square. M get cancelled out. So R is equal to mu G by omega square. What is mu value? That is 0.1. G, let us take it as 10. Okay, so this is in meter. Okay, omega. So this is 30 RPM. So that is 2 pi into 30 by 60. Okay, so this will be 2, that will be pi square. So what is the approximate value that we are having? 0.1. This will be 1 divided by pi square. So 0.101 meter. 0.101 meter. So option C is the correct answer. 0.101 meter. Option C. Right? Clear? Understood? Okay. That means I have to keep the mass at least at 0.1 meter. And if I'm placing more than that, then the body will be overcoming. The body will be in motion. Okay. Body will be in dynamic condition. Exactly at 0.1, the body is undergoing an impending motion. If you are keeping the radius less than 0.1 meter, then the body won't be moving. It will be in the static condition. Is this clear? Yes. Chalo. Perfect. Let's move to the next question. Question number 4. A block which is weighing 10 Newton travels down a smooth curved track AB joined to a rough horizontal surface as shown in the figure. The rough surface has a coefficient of friction of 0.2 with the block. If the block starts slipping on the track from a point of 1 meter above the horizontal surface, how far it will move on the rough surface? That means you have to tell me you are releasing a block. Okay, so it is moving on this is a smooth curved surface. The curved surface is smooth. This is smooth, right? Okay, but the horizontal surface is rough. After point B, the body will be undergoing some retardation. So my question is, how far this block will be moving on that rough surface? What is the displacement? Chalo. Is it 10 meter? Is it 12 meter? Is it 2 meter? Or is it 5 meter? So now, is this a smooth surface? We can directly have the energy equation, the potential energy converted into the kinetic energy, right? I can apply the simple equation, your energy equation, right? Between A and B, I can say mgh is equal to half into m into Vb square, right? So from here I'll be getting Vb is equal to 2gh, okay, 2g root 2gh. That means this will be the velocity at this point. Let us suppose that is, we am calling it as the initial velocity. Okay, it will be traveling some distance. Let us say s is the displacement, and at this point the velocity is equal to 0, because you need to calculate if the block starts slipping from the horizontal track from a point 1 meter up the ground, how far it will move on the rough surface. That means from point B, what will be the net displacement? Okay, fine. Can we try this quickly? Now, if I try to draw the FBD, right? So we are having a friction force. The body is moving in this direction. This is the direction of motion, right? We are having a normal reaction. We are having a weight acting downward. Right? So can we say there is no net force acting? So can we say the frictional force is responsible? The frictional force is basically, or minus of F is equal to mass into acceleration. Or we can say minus mu n is equal to mass into acceleration. So minus mg is equal to mass into acceleration. So A is equal to minus mu g. Why I am saying minus? Because the body is undergoing a retarding motion. Right? So now I can use this retardation. Initial velocity is root 2gh. So can you tell me the value of this? H value is 1 meter. So this is root 20 meter per second. Initial velocity, final velocity is 0. This is the final velocity, which is equal to 0. So we can use simple we can say u square, v square is equal to u square plus 2 into a into s. Okay, fine. So if final velocity is 0, this is root 20 whole square minus 2 into acceleration is mu into g. S we need to calculate. S is equal to 20 divided by 2 into mu into G. So this is 20 divided by 2 into mu value is 0.2, G is 10. So from here I'm getting this value to be how much? This get cancelled, this get cancelled, this is 5 meter. 5 meter. That means the displacement traveled by the body will be 5 meter. That will be the net displacement traveled by the body. So that means when you are releasing this block, this is a smooth surface, right? After this point, because the surface is a rough surface, so it will be undergoing a retarding motion, and that retardation will be definitely stopping the body after some displacement. So that is basically we need to calculate from this particular question, and we have applied a simple, I'm not saying this is a very difficult question, it's a very easy question. Only thing is you need to visualize how you can apply. So normally in this kind of, in kinetics case, you are applying the Newton's second law or energy equation, right, in order to get the results in the very easiest way possible. Very good, Rolex, Harshit, perfect. Kiran, done? Option D is the correct answer. Chaliye, next question on your screen, question number 5. A particle is thrown up vertically with an initial velocity u. The velocity time graph for the motion of the particle considering the upward velocity as positive. How you can represent time versus velocity? Option A, option B, option C, or option D? Chalo. How you can represent the time versus the velocity graph by looking at this? Upward velocity is positive, downward velocity is negative. Option A, B, C, D. Dekho, it's quite easy. You are throwing the body with the initial velocity. That means at time t equal to 0, you will be having some velocity, and that will be maximum. Time t equal to 0 will be having velocity. By looking at the graph, sir, A is not possible, C is not possible. A is not possible, C is not possible. Right? Okay, fine. If you clearly visualize, at t equal to 0, you are throwing the body in vertical upward direction. And when you are throwing, it will be moving with some velocity decreasing magnitude. And the topmost position, the velocity will be 0. Right? So after some point of time, the velocity should be 0. So if you see, after some point of time, the velocity is coming to be 0 at this point. And after that, when it is 0, what will happen? It is going downward, and downward velocity I'm taking as negative. Downward velocity, it is negative, right? So after some time, the velocity magnitude will be negative. So tell me how we need to solve. Is it B or is it D? Is it B or is it D? Sir, clearly, if you look at option B, with the time, velocity is increasing. That means in this case, time is decreasing and velocity is increasing, which is not practically feasible. Okay. In this case, you are at time t equal to 0, the velocity is maximum, right? And once you are increasing the time, right? You're increasing the time, the velocity is decreasing. Okay, fine. Velocity is decreasing. But after some point of time, the velocity is coming a negative. So this is a negative velocity. Can we say option D is the final correct answer? Because in option B, there is no concept of negative velocity. But in option B, we are having a negative time, which is not possible. This is basically not possible. Option B, there is a negative time. You cannot define negative time, right? You are going below the y-axis, negative y-axis, which is not technically possible. So option D is the final correct answer, because at t equal to 0, the velocity is maximum. And with the time, the velocity is decreasing, it is becoming 0. And after that point, the velocity is increasing and it will be surpassing like this. Okay, so option B is the final correct answer. And this type of questions normally you can expect in the examination. Okay, in mechanics perspective, this kind of graphical questions you can expect, because this is actually checking your basic understanding level. Okay, very good. Rolex, Harshit, Rishi, perfect. Chalo, SK, is this clear? Because I think you have given option B is the correct answer, which is not correct. Chalo, next question. A box is resting on a floor with a coefficient of friction equal to 0.4. So mu is equal to 0.4, right? Mu equal to 0.4. Okay, the maximum height h, at what maximum height h may the box be pulled if it is moved with a constant or uniform velocity without overturning? without overturning. Chaliye, try this. A very easy question. You have to tell me what should be the maximum height such that the body has to move with constant velocity. Constant velocity means I'm talking about dynamic equilibrium. Constant velocity means acceleration equal to 0. That means the body is undergoing a dynamic equilibrium. Net force equal to 0. Net moment should be equal to 0. So you have to take all the equilibrium conditions in this particular case. Okay, fine. Draw the FBD. Draw FBD and tell me what will be the free body diagram. If you try to visualize, because they have given a box with some dimensions, so definitely we can say for overturning, this will be the point about where the body will be overturning, and this will be the normal reaction, and this will be the direction of friction. Yes, this will be the direction of friction. Okay, let us suppose this is point O. This is the center of gravity. This will be the weight of the body acting downward. Okay, so you have to tell me what should be the height. So I can say the total, because the body is undergoing constant velocity, that means the body is under equilibrium condition, right? So total horizontal force equal to 0. So P is equal to F, right? And we can say the total vertical force equal to 0, N is equal to W. So I can simply say F is equal to mu into N. So mu into W, that is equal to P. Okay, that is equal to P, right? Now, if I want to have we can say simple conditions, so that means the moment should be 0. So if I try to calculate moment about point O, that should be equal to 0. So W into 30, this is 60, so that will be 30, right? Should be equal to P into H, right? So from here I can get the value of P, that is W into, we have to calculate the value of H, right? So H will be equal to W into 30 by P. P is already we have seen mu into W. So H is equal to W into 30 by mu into W, right? So this is 30 by mu. What's the value of mu you are getting? Mu is 0.4. Mu is equal to 0.4. So 30 divided by 0.4. This is the magnitude. Yes. What is the value you are having? Yes, C 75, 75 mm. 300 by 4, that is equal to 75. And the distance they have given in mm, right? So definitely we have to, this is in mm, so I have not converted that, so it will be 75 mm. Okay, so option C, 75 mm is the correct answer. Simple. Try to understand, because they have said uniform velocity, that means I'm talking about equilibrium condition. You have to take the equilibrium condition. If you're not taking the equilibrium condition, then your problems becomes difficult. Not difficult, then you have to apply the Newton's second law. If the body is moving with constant acceleration, then we can apply the Newton's second law. You can get the value of acceleration, and in that case, we can take some unknown values we can easily calculate, right? But in this case, because they have specifically mentioned the body is moving under uniform velocity, and we can apply the dynamic equilibrium conditions. Okay, fine, clear? Yes, perfect. Next question, very easy. A roller of diameter 200 mm rolls without slipping between the two horizontal strips moving in opposite direction. So we are having a roller 3 meter per second upward, 2 meter per second downward. So you need to tell me at which point the instantaneous center of rotation of the roller lie on the PQ at a distance from Q. That means at what distance from Q the I center will be located. Now, quickly, is it at point Q? Is it at 80 mm from point Q, or is it exactly at the midpoint because the diameter is 200 mm, or is it exactly at point P? If you do some smart work, I think without even solving, you can tell me the answer. If I'm trying to apply the simple logical approach, you can easily solve this question, very easily. Yes, quickly. Rolex, SK, Rishi, Harshit, Kiran. Now tell me one thing. Let's try to analyze in this way. Let us suppose there is a roller rolling without slip. There is a body which is having pure rolling motion. It is having pure rolling motion, right? Tell me where will be the I center located. Tell me, simple. Where will be the location of I center? It will be at the point of contact. This will be because at about this point the entire body will be rotating. Okay, let us take one more example. Let us suppose there is a body which is rotating about the center. There is a hinge point, right? So can we say at each and every point the velocity will be equal? That means the entire body is rotating about the center point. That means over here having the same velocity as that over here, that is r into omega, right? So this is the instantaneous center. Okay, now try to visualize the same example. In this case, there is a roller, right, whose up velocity is 3 meter per second and down velocity is 2 meter per second. Are we not able to visualize that its eye center will not be located at the center point? So we can eliminate option C. Option A is only possible if the top velocity is 0. So we are left out with this. So option D is only possible if the body is undergoing pure rolling motion about point P. So this is not possible. Option B is the correct answer. Without even solving, we have solved it. But we'll be definitely taking the solution for this. Okay, fine. So option B is the correct. Let us see how we need to solve. Now, if I try to draw the your velocity triangle, or simply we can say this is your 2 meter per second. 2 meter per second, right? This is your, let us suppose the center point. This is point Q. This is point P, right? So it will be something like this. I don't know where it will be located. This I'm taking a random point. This is X. Okay, this is X, and this is 200 minus X, and this is 3 meter per second. Okay, 3 meter per second, right? Fine. So now I can say, let us suppose this is the eye center I at a distance X from point Q. So I can say that 3 divided by 200 minus X should be equal to 2 divided by X, and that should be equal to the angular velocity of this particular roller. Okay, so I can simply calculate this is 3x is equal to 400 minus 2x. So x is equal to 5x is equal to 400. X is equal to 80 meter or mm, because they are given it as in mm. So 80 mm, that is a final correct answer. Option B. Is this clear? Option B is the final correct answer. If let us suppose if they are given 2 meter per second and 2 meter per second, up plate and down plate is having equal velocity, can you tell me what will be the answer in that case? If instead of 3 meter per second they are giving 2 meter per second, 2 meter per second and 2 meter per second, can you tell me where will be the eye center located? Exactly the center point, that is 100 mm from point Q. 100 mm from point Q. Okay, if let us suppose your velocity at point Q is 0. If velocity at point Q is 0, that is a pure rolling motion about the lower plate. At the point of contact, 0 velocity. Let us suppose the velocity at point P equal to 0. That is a pure rolling motion and the eye center is at point P. Clear? Eh? Okay, perfect. Very good, very good. So I think you have understood from the single question the multiple concepts you have seen. Okay, next problem from a very interesting topic that we call it as stress. What will be the magnitude of the force on the member BH? Okay, where is that BH now? Are you able to see the diagram? Yeah. What will be the force in this member? What will be the force in this member? Can you tell me? Sir, if I try to approach by using method of joint, if I try to go with method of section, sir, very difficult. Let us try to analyze a simple concept. Now, if you try to see the joint I, there are two collinear forces and the third non-collinear force. So definitely this BI will be having a 0 force member. BI is 0. So if I take now the joint B, at joint B we are having this kind of situation. FBH, this is FBC, this is FBA, right? So again BA and BC are collinear, so we can simply say FBH is also a 0 force member. This is equal to 0. 0, 0. Simple technique. A simple technique to identify the 0 force member in trusses, and normally you are getting these kind of questions. Okay, normally you are getting this, and here also try to expand our discussion. Here we'll be having DJ the 0. This is also 0, right? Okay, these two are zeros. Apart from this, any other member that is having 0? No, that's it. That's it. Yes, Hana. Okay, Is this clear? So here we are having the force in the BH member is coming out to be 0. Option A is the correct answer. Let's proceed and let's move to question number 9, the second last question of today's session. Okay. A plate is held by a chain AB. There's a chain being kept with a plate, right? I'll be showing you the diagram. It's something like this. Plate is pulled by a force of T. The plate is pulled by a force of T. What should be the tension in the chain? What should be the tension in this chain? What should be the tension in this chain? That means they're asking what's the value of TAB. What is the value of TAB? Chalo, let's try. Let's try this. Okay. What will be the tension? Definitely the body is in equilibrium, right? The body is not moving. So we can draw the free body diagram. We can draw, very good, very good. So we're having root 3 by 2t, root 2 by 3t, or t by 2, or 3 root 2t. Perfect. So if I draw the FBD, free body diagram of this rod, then you will be having this rod, right? This is the T force, right? And this is TAB, which is making an angle of 45 degree. This is 45. This is also 45. Right? Okay, that's it. So if I try to take the moment about the hinge point, that should be equal to 0. So what's the total length? That is 3L. So T into 3L minus, now only the cos component will be responsible. So TAB cos 45 into L equal to 0. Okay, so here we can say T into 3L is equal to TAB into cos 41 upon root 2 into L. L get cancelled out. So we are having TAB is equal to 3 root 2T. 3 root 2T will be required in order to make this body to be in a horizontal position or vertical position. Clear? Simple FBD analysis. That is the best part. Like all the topics, even if you are talking about equilibrium, if you're talking about the kinetics, even if you're talking about the energy topic, so all the topics are related to each other. And many questions we need to apply the logic, combination of different logic, like energy equation or the kinetics equation we need to apply in order to get the correct answer. Okay, option D is the correct answer. Chaliye, next last question on the screen. A uniform rod of length L equal to 1 meter and mass 2 kg is suspended with the help of two massless strings as shown in the figure below. Calculate the tension T in the left string at the instant when the right string snaps. That means when the right string breaks down, what will be the tension in the left string? What will be the tension in the left string? Chaliye. If right string, it's basically you are cutting the right string. Okay, then how much tension will be exerted on the left string? That is the question. Something like this. Fine. So let us draw the free body diagram. This will be mg acting, right? There is a tension T. Okay. So technically the body is in motion. The body will try to move, right? So I can say your mg minus T equal to m into acceleration in the y direction. I'm only talking about the acceleration in the y direction. Yes? Yes or no? And if I talk about the circular motion, can I say if I say the moment about the center, if I take the moment about point center, I can say T into L by 2 is equal to I into alpha. If I'm taking the moment of inertia about the center point, so T into L by 2 is equal to, that is ml square by 12 into alpha. So from here, 1L get cancelled out. So T is equal to m by 6 into L into alpha. Right, L into alpha. And also can we say that acceleration in the downward direction should be equal to L by 2 into alpha. L by 2, like we can say R into alpha, right? We are taking the point about this point. So L by 2 into alpha. So just using this equation, are we not able to get the value of AY? Let's calculate the value of AY, right? So from here, this will be m by 3 into L by 2 into alpha. This is AY. So T is equal to MAY by 3. So placing this value in this equation number 1, okay. So mg minus may by 3 is equal to may. So mg is equal to, this will be 4 by 3 may. M get cancelled out. So acceleration in the y direction is equal to 3 by 4 g, or 3g by 4. So once you are getting this, you can place this over here. So t is equal to m ay by 3. So m into 3 by 4 g. So this is mg by 4, right? And what is mass? I think they're given as 2 kg. You can take g is equal to 10. Okay. So 2 into 10 by 4, that is 5 Newton. That means on the string, on the left string, you will be exerting 5 Newton of force. Simply 5 Newton of force will be exerted. Is this clear? Question is very easy. Only thing you have to just proceed in a systematic manner. That's it. Correct. Very good, Rishi. Very good. Correct answer. Option A for 5 Newton is the final correct answer. Initially, let us suppose it was not being snapped out. So, what was the tension in this both the springs? Because that in that case, the rod will be stationary. So, 10 Newton each. Yes. 20 G. Yes. Yes. Yes, 10 Newton. But once you are just snapping at that particular instant, your tension becomes reduced because now the body is in motion. Now the body is trying to move. Okay, fine. So here we are getting the tension on the left string is coming out to be 5 Newton simply by taking a simple FBD analysis. Okay, fine. So this completes today's session on the practice of the mechanics topic, right? And I'll be uploading this PDF for your reference on my Telegram channel where you can download it. Okay, so thank you guys for joining with me. I hope you all enjoyed this. Before leaving the session, please do like and subscribe, and definitely you might have subscribed. If not yet subscribed, please do subscribe, right? And for all such awesome content, stay connected with our own BYJU'S exam. Thank you guys. Bye bye. And before leaving, please do like the session. Thank you. Bye bye. Take care.